Grade 9 academic course, parallel and perpendicular lines. And basically we're going to identify based on an equation whether lines are parallel or perpendicular. Okay, that's the goal for today. Here we go. So parallel lines, just to make sure you're clear on what they are, they're lines that run in the same direction but they never cross. They always have the exact same slope, and then they usually, unless it's the same line, have different y-intercepts. And just how we often denote them is little arrows like that, or maybe even two, and that just says to me that those two lines are parallel. Okay? Perpendicular lines are lines that intersect at right angles, and this little box here means a right angle. It means 90 degrees. When we say right, we mean 90 degrees. And that's what I meant to say here. Like, this thing here is supposed to represent this. You can tell if you happen to have a picture that shows this little thing, that's an indication that it's a perpendicular line. Okay, and just the other thing is sometimes I use this. This is our short form way of saying perpendicular. So if I was saying x is perpendicular to y, or 3 is perpendicular, whatever, something's perpendicular to something else, that's the line. It's a short form way of saying perpendicular. Much nicer, I think, than that. So you're going to see this a few times. I want to remind you again, by the way, that if I start going quick, that you are more than welcome to stop the tape. Okay, so here I just give some examples and what the equations look like for parallel and perpendicular lines. So let's totally focus on these two, which are two parallel lines. Okay, so we're starting here with these parallel lines here. And looking at the top line, I want to find the equation for it. So I've identified the y-intercept. I know you've done this before. And I'm going to find 2 points. So here's 1 point. Oh no, I think I have them already. Yeah, here's the 2 points. You can just hardly see them, that's all. So I chose these 2 points and find the rise and the run. So the rise is 1, 2, 3, and the run is 1, 2, 3, 4, 5. So my slope is 3 over 5. Okay, looking at this one, my y-intercept is -2. And if my 2 points, if you can't see them very well, are right there. And it's the same thing. My rise is 1, 2, 3, and my run is 1, 2, 3, 4, 5. So slope is 3 over 5. So just looking then at the equation for the two lines, they're both the same m, but they have different y-intercepts. Okay? On this one, these two perpendicular lines, here I've got, if we take this one right here first, okay? And here's a point, and here's a point. My y-intercept is 3. And taking my 2 points, my rise is, remember the one thing when you're doing your rise, just to be clear, because this could be confusing. Well, if it looks like this, you know your slope is negative. That's maybe the most important thing. But when you do your rise, you think of your points as going from left to right. So my rise is -2, okay? My rise is -2, and my run is 1, 2, 3. So my slope is -2 over 3. And again, just if ever in doubt, I mean, this is a negative slope, this is a positive slope. If you get a little jazzed up over which is which, just go by the appearance of it. At the end, this has to be a negative slope and this is a positive slope. Okay, so I've got my slope and I've got my y-intercept on this one here, and I'm doing this quite quickly. Here's my y-intercept at 1, and I have a second point right here. So my y-intercept is 1, and my rise is 1, 2, 3 to get to here, right? 1, 2, 3, and my run is 1, 2. 3 over 2. So just noticing the connection between this and this, okay? So my slope, my equation for one line is -2 over 3x plus 3, and my equation for the other one is 3 over 2x plus 1. So I want you to notice, because the y-intercepts are sort of indifferent on parallel and perpendicular lines, they don't matter. The slope does. Here the slope's the same, and you should notice something interesting about that slope, okay? And what it is they're negative reciprocals. And what that means by negative reciprocal is you turn the fraction upside down and give it the opposite sign. And essentially, the slope of perpendicular lines are negative reciprocals. So in this case, state the negative reciprocal of the following slope. So if my slope was 2 2, remember, is 2 over 1. Same thing. So my perpendicular slope, or my negative reciprocal slope, would be turn it upside down and give it a negative sign. Okay? In this case, if my slope was negative 1 over 2, I would turn it upside down and you change the sign, right? Make it from negative to positive. Okay? Which is just 2. This one, 1 is just 1 over 1, so it would be turn it upside down, whatever, and it's negative. Okay, and remember that sign there just means perpendicular. You can write all that out if you want to. I'm going to move on, so you should write all that out. Just make sure that you pause the tape, because I'm going to move on. Okay, so quite simply, give the equation of a line that is parallel to and perpendicular to this line right here. So the slope is the same for parallel line, but the y-intercept could be anything. So I just threw in 2. It could be anything I wanted. So you write the exact same equation, just a different y-intercept. So you could have done 7.8 if you wanted to, or 32, or whatever. This one doesn't matter very much. This one matters a lot. Okay? Perpendicular, the slope is the negative reciprocal, so that would be positive 2 over 3. And then again, this one doesn't matter. The y-intercept doesn't matter. But this matters a lot. Okay. Give the equation of a line that is parallel and an equation for a line that is perpendicular to standard form. So the strategy is, really just rearrange it to y equals mx plus b form. Okay. So the step is rearranged. So how we do that is first rewrite the equation and add 3y to each side to begin. That's the very first thing I did, okay? So I added 3y to each side. You end up with 2x plus 1 equals 3y. I flipped it around, so I have the y's on the left. Then divide each term, and again, I can't say how important it is. You divide each term by 3, you divide each term by 3. So divide this by 3, this by 3, and this by 3 to end up with y equals 2 over 3x plus 1/3. Okay? Just, by the way, 2 over 3x. This is my typed way of saying. Okay? So a line that's parallel to that then could be, again, exact same slope and just anything here. I just chose 3. I could have chose anything. Perpendicular is the negative reciprocal, so flip it around, right? Flip it around and give it a negative sign, and again, just whatever. Okay, moving on. This is interesting. Right triangles. So, for me to be able to say that this was a right triangle, I would have these two. That was the wrong word. Don't write it. For it to be right. For it to be a right triangle. The line segments AB, so this is the line segment AB right here, and AC must be perpendicular. So if I knew the coordinates of those points, if they were on a grid somewhere, I could know if that was actually perpendicular. It looks perpendicular, but we don't actually, I'm not going to write this in here because I don't know that for sure that it is. I don't know that unless I know the slopes of these lines. So, again, if you need more time there, go ahead. But let's do this example here. It's saying, determine whether or not the following sets of points form a right triangle. So here's the points. I believe, the first nice thing to do to start is to sketch it. You don't really have to do that, by the way. It's just that you don't have to do that, but I did, okay? And I know my coordinates here. So it looks like it might be right. I guess that's a good start, right? And when I look at this, I say, okay, if this is a right triangle, then AC must be perpendicular to AB, okay? Then it's right. So how do I know that? Well, I find the slope. So find slope of AB. And think rise and run. So the rise is 2. And the run is 2. so it's 1. The slope of AC is, the rise is -2, and the run is 2 equals -1. And 1 and -1, in fact, are negative reciprocals of each other, because if you flipped it upside down and made it negative, it would be. So I'm going to draw my little negative in there, or sorry, not my negative, my perpendicular sign, and say, yes, they are perpendicular. It is a right triangle. Yay. Okay, so what I did again, found the slope of each of those two, found that they were negative reciprocals of each other, because if I wanted to find the negative reciprocal of 1, right, I'd say that's 1 over 1, right? That's what that is. So the negative reciprocal would be -1 over 1. So, okay, last example. This one's pretty tough, I think. So I've got 2 points, and then it's asking, well, what could point C be if I wanted this to be right? Okay? So start by plotting the points, so the points that I know. So there's 2, 2, there's my A, there's my B down here, and I need to find out, this is the answer, but I gotta show you how you came up with that. How do you pick C so that this thing is right? Well, first thing I did, is find the slope of AB. Okay, so I drew AB and I found the slope. And the slope of it was -8 over 3. And I know that because between A and B, the rise is 1, 2, 3, 4, 5, 6, 7, 8. Down 8. Okay? Down 8. So my rise is -8. And my run is from 1 to 3, is 3. That's how I came up with slope of -8 over 3. So my perpendicular slope would be 3 over 8. Okay? So all I did here, I just needed to use my new slope from A, because I want to make a right angle right here. So I need to draw a line segment here that's perpendicular, so it has to have this slope. So then I just used my rise of 3, 1, 2, 3, and my run of 8, 1, 2, 3, 4, 5, 6, 7, 8, and that's how I found point C. Just read the coordinates off the chart. Okay, and it's 2, 4, 6, 8, 10 in the X, and 5 in the Y. Okay, that's a tough one, but you know, that's all you do. It's the same skill, just a tough question. So that was a fairly long video, and I suspect you might need a little bit more time with it. So if you do, if I went quick, please take the time to make sure the note is complete and bring it to class tomorrow.